Today we're going to combine what we know about linear functions and quadratic functions. So we're going to look at when linear functions intersect parabolas. And there's different ways that this can happen. So how many times can a straight line intersect a parabola? We can get this situation. So we've got a straight line here, which is 0, i.e. the line misses the parabola completely. And that's a very feasible option. Okay, we can get one intersection. Okay, so what can happen is the parabola or the straight line runs and kind of just nicks the parabola right at one very specific point. So that's going to be one intersection, and we call this runs at a tangent. Okay, so the one intersection, we call that the line runs at a tangent to the parabola. And of course, what we could also get is two intersections. Okay, so that would be where the parabola and the straight line intersect twice, once there and once there. So these are the three variations that we can get. So when solving a pair of simultaneous equations involving a parabola and a line, we may obtain 0, 1 or 2 solutions. Okay, and we tend to use the method of substitution to actually get solutions. All right, determining the number of solutions or points of intersection. So what we can do is once we've equated the two things off, we can use the discriminant check to see how many intersections we're going to get. So there's going to be no solutions when the discriminant, this thing here, is less than 0. There's going to be one solution, i.e. a tangent, when the discriminant is equal to 0. And when the discriminant is larger than 0, we're going to get two solutions. So let's apply this understanding to solving simultaneous linear and quadratics to the following. All right, so determine the number of solutions or points of intersection between the following pairs of equations. Right, so we want to line these up. So what we're going to do is to find where they intersect, let's let them equal each other. So this is y equals and y equals. So y is this, so we're going to rewrite it as x take 2 is the same as x squared plus 3x take 1. Okay, and when we solve for x, what's going to happen is it's going to tell us the x value where they're exactly the same. Now, to determine the number of solutions, we want to run the discriminant check. And remember, the discriminant is b squared take 4ac. And that depends on the equation being written in ax squared plus bx plus c equals 0 form. So we need the a, the b, and the c. Now, notice how this equation it isn't in the required form. So what we're going to do is just quickly transpose it. So I'm going to subtract x and add 2 from the left-hand side. That's going to mean that the left-hand side is equal to 0, x squared. So I'm going to subtract x from both sides. So that leaves me with 2x there. And plus 2 is plus 1. All right. So that's our equation now. Now we can run the discriminant where it's b squared take 4ac. A value is 1, b value is 2, c value is 1. Discriminant is b squared, 4, take away 4 times 1 times 1. Discriminant is equal to 0, okay? So what we're suspecting is that if we graph these, and we're going to do that. So I'll graph x squared plus 3x take 1. And I'm going to graph the linear as well, which is x take 2. What I'm suspecting is that they will intersect at one point only. And there it is, right down there. Okay, so that point there is where they intersect. So it's one single point. And remember what we call that line, we say that it runs at a tangent to the parabola. All right, let's do the same thing for this one. So we're going to go 5 take 2x equals 2x squared take 3x plus 8. All right, I can't run the discriminant check on it in this form. I need it in ax squared plus bx plus c equals 0 form. So what I'm going to do is subtract 5 and add 2x to both sides. That will leave the left-hand side equal to 0 and the right-hand side equal to negative x. Take 5 is plus 3. All right, discriminant is b squared take 4ac. Where a is equal to 2, b is equal to negative 1, and c is equal to 3. All right, let's throw them in there. So we've got negative 1 all squared is 1, take away 4 times 2 times 3. I'm afraid, girls, that this has 824. Discriminant is equal to negative 23. And what we're going to say is discriminant is less than 0, therefore no intersection. This one over here, let's interpret it. Discriminant is equal to 0. Well, I've just said that. So therefore, one intersection is our answer to that one. Okay, so just make sure you update your solution there. Discriminant equals 0 by itself means nothing. You've got to actually interpret it. So again, let's just graph that to see or confirm that the linear function is going to totally miss the quadratic. Yeah, there's that, and 5 take 2x. All right, reveal the truth, graphs. Oh, it missed completely. Okay, so the discriminant check suggests that there's no intersection, and the graph confirms that these lines will not intersect. All right, determine any points of intersection of these parabolas and lines. So what we've got is x squared take 3x, and we want to know whether the line y equals 4 actually intersects with it. So we're going to go 4 equals x squared take 3x. Now remember, we need to solve this for x, which means that I can't just factor out x and apply the null factor law. To do that, I need the left-hand side or the right-hand side to be equal to 0. So I'm going to rewrite this as, I'm going to subtract 4 from both sides, x squared take 3x take 4. And now what I'm going to do is, the eternal optimist in me will say, let's try the cross method on this. And that is going to work for us nicely. So x plus 1, x take 4. All right, so what are the solutions? X is equal to negative 1, and x is equal to 4. All right, so we're going to list them as an ordered pair or coordinates. So our x-intercept for each of them is going to be negative 1 and 4. What's the y value going to be? Well, interestingly, girls, it's not 0. Okay, so these are not the x-intercepts. What these are the points of intersection between these two lines here. So they intercept at negative 1 as an x value, and it's going to be 4 as a y value, because what we've said is, when is this parabola here equal to the value of 4? So this is also going to be 4, 4. Let's again check that out. So you should be doing, as part of what you do, you should be graphing these things and just having a look and seeing whether that's right. 3x and 4. Let's have a little bit of a look at the two graphs. There they are there. Right, and you've got analysis, G-solve, and an intersection. And we can see that one of the intersections occur at negative 1, 4. That's that one there. And the other one, by just moving left and right, you can move between the intersection points, is at 4, 4, which is that one there. Yet another way to find out where they intersect is to go into main. And what we do is we grab the simultaneous equations template and type in our equation. So y equals x squared take 3x and y equals 4, solving for x, y, and it gives us the two ordered pairs. All right, let's try this one here. So we're going to go negative 2 equals x squared plus 2x plus 4. All right, so now what I'm going to do is add 2 to both sides, x squared plus 2x plus 6. Okay, and what I want to do is check when this is equal to 0. So let's attempt a null factor law. So we'll try to factorize. So it's going to be 6, 1, 2, 3, x. Nope, it's not going to factorize. All right, so what is the problem? Well, does this actually have, or will it ever equal 0? That's my question. And what we can do at this point is actually find out by doing a discriminant check, b squared take 4ac. Because I suspect, because I can't null factor law it, I might be able to quadratic formula, I might be able to throw this into the quadratic formula, but let's just check whether it has solutions first of all. So we're going to go b squared take 4ac, where a is equal to 1, b is equal to 2, and C is equal to 6. Discriminant is 4, take away 4 times 1 times 6. My suspicions are correct, girls. 24. Discriminant is equal to negative 20. Therefore, no solutions. Okay, so again, if you check this on the calculator, what you would find is that this line here, in fact, let's do it, stuff it, let's do it. All right, I want to have a look. So we got x squared plus 2x plus 4, and I want to know when the line y equals negative 2 hits it. I'm afraid, whoops, I forgot to graph it. It's clear that it doesn't hit it. There's the line y equals negative 2. There is the parabola. The question we're asking is, when does this line hit this line here? The answer is never. How do I know? Because the discriminant check was less than 0. All right, we want to know when this line here, y equals x squared, intersects with y equals 2x. All right, so let's set it up. We're going to go x squared equals 2x. All right, now don't forget, you can't divide through by x because that assumes that x can't be equal to 0, and it might be equal to 0. So we're going to go x squared, take 2x equals 0. So what I've done is subtracted 2x from both sides. Bring x out as a common factor. Solve via the null factor law. X equals 0, x is equal to 2. All right, now remember, we're going to state these intersections as coordinates, so 0 and 2, but don't actually put 0 and 0 there. These are not the x-intercepts this time round. What they are is the intersection points. So what you've got to do is actually bang these values back into one of the functions, either of them, and you'll get the y value. So 0 goes in, 0 squared is 0. 2 goes in, and the answer is 4. Notice that if I put it in the second function, it's also 4. So what this is suggesting is that we've got two intersection points, one at 0, 0, one at 2, 4. Okay. Now notice also that I didn't run the discriminant check on that one, and that's because I knew I could quickly factorize it. So you don't have to run the discriminant check on everything, just the ones that you kind of don't like. All right, this one here. So what we're going to do with this one is we want to run the method of substitution. This one here doesn't have y as the subject, but that shouldn't stop me. I can make y the subject quite quickly by going negative 3y equals negative 2x take 4. So what I've done is subtracted 2x from both sides. Now I'm going to write it as y equals 2x on 3. So I've divided by negative 3 plus 4 on 3. All right, I'm going to rewrite that. Now I know that this move is going to help me out, so I'm going to write it as one big denominator, okay, all over 3. Now I'm going to equate them off. So I'm going to go 2x plus 4 on 3 equals x squared plus 1. All right, now what I want to do is let the left or the right-hand side equal 0. So the way I'm going to do that is get rid of this 3 in the denominator by going 2x plus 4 equals, and multiply all of the right side by 3, 3x squared plus 3. All right, now let's subtract the things that are on the left-hand side. So take 2x and take 4. So I've got 0 equals 3x squared, take 2x, and I've got 3, and I want to remove 4, so that's take 1. All right, so what is evident here, girls, is that this will be a quadratic formula solution, okay? So maybe it won't be. Let's just check whether these actually intersect with each other. So we'll go discriminant equals b squared take 4ac, where a is equal to negative 2, b is equal to 3, c is equal to neg 1. b squared, 9, take away 4 times negative 2 times negative 1. Okay, 9 take away 4 times negative 2 is negative 8. Negative 8 is 8. Discriminant is equal to 1. All right, now this is interesting, okay? I've just assumed that this will be quadratic formula, okay? But I actually know that I could factorize this via the cross method. Now, why do I know that? Because the discriminant came out as a perfect square, okay? So I know that I could have done that, Okay, so just check that if your discriminant value comes out as like 1, 4, 9, 16, 25, that what you could have done is you could have factorized it via the null and solved via the null factor law at this point here. Okay, so I'm going to revert to that and not proceed with the quadratic formula because I know I should be able to factorize it. So I've got 3x, x, 1, 1. Now this one is going to be negative. So we're going to go 0 equals 3x take 1, plus 1 rather, and x take 1. What are our solutions? X is equal to negative 1/3, x is equal to 1. All right, so now we need our y values. So y and y equals, so when x is equal to 1, what we do is we just go up and have a look at the easiest one to sub values into. So it's going to be this one because 1 squared is 1, 1 plus 1 is 2. So there's one of our ordered pairs, 1, 2. Now we're going to bang negative 1/3. Let's pop it into the first one as well. I think that's going to be the easiest. So negative 1/3 squared is 1/9 plus 1, which is plus 9 over 9. Y equals 10 over 9. So our second ordered pair was negative 1/3, comma, 10 over 9. Try that again. All right, so again, good for you to see me think or assume that I wasn't able to factorize that because again, I know that when the discriminant comes out as a perfect square, that I could have actually factorized it. But if you actually proceeded with the quadratic formula from here, you would have got those solutions out, no worries. Okay, our last problem is this one here. So again, not too sure what's so different about this one, but let's just try it out. We'll go 2x equals x squared plus 5x take 5. And we've got 0 equals x squared plus 3x take 5 once I subtract 2x from both sides. All right, I do suspect that this will be quadratic formula. Okay, so x, yep, I'm afraid this is quadratic formula. Okay, so what I can quickly see is that I can't factorize it, but let's just check whether it does have solutions by throwing it into the discriminant, where a is equal to 1, b is equal to 3, and c is equal to -5. Alrighty, now b squared is 9, take away 4 times 1 times -5. That is going to be 9, 4, 20, -20, take -20, discriminant equals 29. Okay, so we do have solutions, it's 2 solutions, and we do need to proceed with the quadratic formula now because 29 is not a perfect square, unlike 1. All right, so let's finish off the quadratic formula. X equals -b. So feel free to look that up. I just remember it. So it's -b, which is -3, plus or minus the square root of b squared take 4ac. Now that's that part there. That's just the discriminant. So we're going to throw 29 straight in there, all over 2a. That's why running the discriminant check is also a useful thing because you're going to need it if you need to proceed with the solve anyway. So that's not time wasted. All right, so there is our 2 solutions. So one of the solutions is going to be, so it's going to have an x value of -3 plus root 29 over 2. The other solution, and I'm just drawing all over my notes here, -3 take root 29 over 2, comma, comma. Now what we've got to do is substitute that x value into one of these functions. Now if you subbed it into the first one, well, good luck with that, you're a glutton for punishment. Okay, have a look at this other one here, this second function. So it doesn't matter which one you sub it into, but certainly this one here is going to be easier because all it's going to do is multiply both of these solutions by 2 or double them. Now notice how that they're both being halved at the moment. So when I multiply the x values by 2, what that will do is just simply cancel out the over 2. So actually the y value is going to be -3 plus root 29. This is going to be negative 3 take away root 29. Right, so when I say it doesn't matter which one you sub it into, it certainly doesn't. But if you had have chosen to sub it into the first one, then it would have just taken you ages to work this all out, and it would have come up as negative 3 plus root 29 when you subbed it into that, and it would have come up as that when you subbed it in for this particular x value. Okay, so some of them are easier, some of them are harder, based on what you choose to substitute it into. Right, so there's your practice, girls. 7G, those questions there.